Alright, this is 06. Notes combine like terms. Your objectives, you'll be able to solve equations with multiple terms that are alike. In math, we have terms. What is a term? A term is a set of mathematical components that represent a situation. There are 4 components in each term. So 4 parts to the term. These 4 parts are: there's a plus or a minus sign in the beginning. There's a whole number, fraction, or a decimal. There's a variable or a symbol. And there's an exponent to that symbol. Now, not all of them are going to be written out all the time. Like what we see here, we have a plus 6x squared. We have a minus 4b squared and a minus 11.6 cubed to the third. As you see, you also grew up with numbers like positive 1 and positive 2 where the variable and the exponents aren't written. But those are also terms too. Sometimes they're just not written always out. Not all of these will always be written down. For example, we have 11x, that's a term. There's an imaginary 1 on that x for an exponent, and there's an imaginary plus sign in front of that 11. But we don't have to always write it. Negative 1x squared, or sorry, negative 1x to the first power. The 1 isn't written there, and the 1 in the power, the exponent, is not written. Same story there. There's an imaginary 1 of that negative 1b to the 5th. Imaginary 1 on the exponent, imaginary 1 there in that exponent, and everything's written out there. If we even just have the number, so we have negative 1, but no x. There's actually an imaginary symbol to the power of 0. Anything to the power of 0 is just 1, so something to remember. Any variable to the power of 0 is equal to 1. This is why we don't bother writing a variable to the 0 power in math, because 5 to the power of 0 is equal to 1, 6 to the power of 0 is equal to 1, and anything times 1 is just itself. Alright, in order for terms to be alike, they have to be on the same side of an equal sign. They also need to have the same variable, and they need to have the same power to that variable. So like down here, the plus 4x to the 5th is one term, and positive 7x to the 5th is another term. We can combine these terms because both of them have the x to the power of 5. So 4x to the 5th plus 7x to the 5th gets you 11x to the 5th. So it'll be positive 11 x to the 5th. That'll be our answer. Alright, looking at this. We have negative 8x minus x equals 0. Now we have to remember, there's an imaginary 1 in front of that x there, and in between the negative sign and the x. So negative 8x minus 1x gets you negative 9x is equal to 0. Divide both sides by negative 9. These will cancel out, and you're going to get x equals 0 divided by negative 9 is just 0. So for this example number 1, it's going to be D, 0. Here's some work. Alright, looking at number 2. We have 1 plus 4a plus 6a equals 21. Now plus 4a, that a has an imaginary little 1 on it. So does this positive 6a. There's an imaginary 1 in that exponents. Since it's a to the first and a to the first, we can combine those terms. So 4a plus 6a gets us 10a to the power of 1. And then this plus 1, technically they're not like terms, that 1 and the 10. So that's why we can't combine them. The 1 doesn't have an a to the first. The 10 does. So we have to still keep them separate, because they're technically not alike. so equals 21. We then do our two-step equations like we practiced before. Subtract 1 from both sides, and we get 10a to the first equals 20. And then to separate the 8 to the first and the 10, you divide by 10 to both sides. And you're going to get 8 to the first is equal to 2. Next up here we got example number 2. And all the work for it there. Next up is example 3. Well, this is 1x to the power of 1 minus 8 minus 4 equals negative 15. Now, the negative 8 doesn't have an x or any variable, and neither does the 4. So these two can be combined, negative 8 and minus 4. So you're going to get 1x minus 12 is equal to negative 15. We add 12 to both sides. I'm going to get x equals negative 3. That's why we get C. Alright, looking at number 4. There's negative 8b. There's no other b's to combine like terms. However, there's two constants that can be combined. So assign the number without a variable. This is called a constant. So we have a positive 2 minus 3 gets us negative 1. Then we have a minus 8b is equal to negative 9. We add 1 to both sides. And we get negative 8b is equal to negative 8. Divide both sides by negative 8. And you get b equals 1. So answer number 4 is also D. B equals 1. Number 5 here, we have 8b minus 1b because there's an imaginary 1 in between the negative sign and the b. So 8 minus 1 gets us 7. So we have 7b is equal to 21. Divide both sides by 7, and we're going to get b equals 3. Alright, problem number 6. So this is problem number 6, so we'll keep that out. So we have a positive 4x. That positive 4x to the power of 1, well, that matches up with the 7x to the power of 1. Because remember, that's an imaginary 1 up there in the exponent. 4 plus 7 gets you 11, so we have 11x to the power of 1. This 8 gets paired up with the negative 3. 8 minus 3 gets us 5. And then equals 24. Continue practicing our inverse operations, so we do minus 5 to both sides. So we have 11x is equal to 19. And this is going to come out to an ugly decimal here. So x is going to turn out to 1 point something. Put it in the calculator. I think I got it right here. X is equal to 1.727. And it's going to be repeating, so it's bar notation. So 1.72 bar notation. Alright, look at problem number 7. We have a plus 3b. That matches up with the 7b. So 3b plus 7b gets us 10b. 11 minus 13 gets us minus 2. That equals 46. Add 2 to both sides. And we get 10b is equal to 48. Divide both sides by 10, and we get b equals 48. Or sorry, b equals 4.8. Because 48 divided by 10 gets us 4.8. And problem number 8, even though they're getting bigger and bigger, we can handle it. 9b minus 2b gets us 7b. And then 7b minus 4b gets us 3b. So we have 3 b's total. 16 plus 73 gets us 89, so positive 89. It's equal to 126. Subtract 89 from both sides. We get 3b is equal to 37. Divided by 3, I think you're going to get another decimal there. You're going to get 12.3 bar notation. Number 9. 3b plus 1b gets us 4b. 4b minus 2b gets us 2b. 24 minus 43 is going to get us a negative 19. And that's equal to 64, so it's okay if it's on the right side. It's still the same story. Just combine everything with the right side. We then add 19 to both sides. We get 83 is equal to 2b. We divide by 2 to both sides, and we're going to get b equals 41.5. So they get a little harder because they got some decimals. That's okay, you could just put it right into the calculator. Number 10. 18b minus 11b gets us 7b, and 7b minus 4b gets us 3b. 54 minus 73. That gets you 13 plus 6, which gets you 19. So this is negative 19. Equals 105. We add 19 to both sides. 105 plus 19 gets us 124. 124 equals 3b. Divide both sides by 3. And you're going to get 41.3 bar notation. Now, number 11. Even with hearts or different symbols, it's still the same story. 10 hearts minus 2 hearts gets you 8 hearts. 8 hearts minus 3 hearts gets us 5 hearts. So we got 5 hearts. 94 minus 14 gets us 80, so we plus 80. Subtract 80 from both sides. We're going to get 25 is equal to 5 hearts. Divide both sides by 5. We're going to get 5 is equal to heart, or hearts are equal to 5. There's your classwork. If you have any questions, feel free to email me or come next job. I'll be happy to help you out. All right, have yourself a good night.